Thank you.
Great. Thank you very much, Jim. Appreciate that.
Okay.
Now, we have time for discussions. Let me ask Norm to come also here. We want to hear from you if anything we missed on our action list of action items. We want to make sure that we are not missing anything. One suggestion was obviously a special variation of ground motion, which is...
Can we open up something and just type in there while we're talking?
Exactly. So
I would start out, though, let me interrupt a little bit and say, terminology is a terrible problem for us right now. I think the discussion we just had between Jim and Gabe was a little bit mixed up of what people think of sigma. So when Gabe says sigma, he's combined the aleatory and the epistemic uncertainty in the sigma mu into one total sigma because that's what he's after, right? Whereas when I was sitting there hearing it, I'm thinking sigma is just the aleatory part. So before we go any further, we've talked about that. We need to write something down that says, here is our clear terminology.
Absolutely.
We will...
Dictionary.
Definition.
And dictionary.
Absolutely. So the audience, you need to speak into the microphone. I'm going to be strict here.
Okay, thank you. Yeah, we were just saying that among our sets of documentation, we need a parameter term, acronym, dictionary or report that everybody's working off the same thing, and that will be I think that needs to be one of the project documents.
Absolutely. That's
and little nice figures.
Figures that will describe, right, something
yes.
simple. I think we will start by no more sigma for intra. Okay, we're going to use the next Greek letter U, if anybody knows whatever that is. I think we can use sigma total if we're going to ever use that for what Gabe talks about, which is when you're trying to fold epistemic and aleatory. But our goal here is to really get at those two pieces separately. We want to get at what the aleatory part is and get at the epistemic parts, not just a single total number.
That's a great suggestion. Gabe, you had a suggestion?
Actually, just one clarification. My thinking at that moment was more between non-ergodic issues, I guess, which has to do with that in terms of what you move into epistemic.
Right, but if we go non-ergodic, then the aleatory sigma is small.
Yeah.
Exactly.
Okay, and so that's what Jim would say. Okay, the sigma is very small, 0.2 or some little number.
Okay.
Yet you might have a very large now sigma mu. Your epistemic uncertainty is where you were centered becomes large, and you need to track that.
Okay.
And if you have data, you can collapse that down. And the precarious rocks are an indication of where you might be in terms of that sigma mu term. But we're going to get nowhere until the terminology is just completely fixed.
And we have to make it mandatory. Or you have to make it mandatory.
This project will use this.
Gabe, you mean in the U.S. or international?
In the project.
No, in the project. So it means international. I just want to make sure that Julian...
These guys, I think, have agreed. The terminology has to get set. In this project, it will be a requirement that you'll use this common terminology.
That's great.
I agree.
Any other suggestion? Anything? We just want to make sure that we don't come back in a couple of years and we miss any key issue.
But this isn't the only time you can tell us things, too, right? This is the beginning.
Yeah, exactly.
It's going to evolve.
Absolutely.
I think, questions that I think Jim brings up here is what are stable continental regions? Can we go down to Baja? I hadn't thought of that as a stable continental region, but it may have some of those aspects, and we're data poor, so we need to borrow from wherever it is relevant. Julian.
I want to ask a question, and it's really, Annie, I'm going to have to take you off whatever you're doing for a second. Okay, or to you or John. Because there's an important, in Gabe's presentation, he said what we want from the hazard, PSHA is the mean hazard. Okay. We have disagreed publicly about this. But I will agree with you. We do want the mean hazard. But is it all we want? Because if we also, I mean, we have to remember that, we started this morning with Larry introducing the SSC project. And this is part 2. And together, each one of them by themselves are not much use. It's putting them together into PSHA for critical facilities in Central and Eastern United States is what this is ultimately all about. My understanding of the way risk analysis is done in NPPs, it doesn't just need the mean at the end of the day. Fractals are also needed. And if that is true, then tracking the difference between epistemic and aleatory is vitally important.
Sorry, we're monopolizing the discussion. It is important. You want to, well, traditionally, it has been shown, and I'm not claiming that you should only go to the mean hazard. But on the other hand, when it comes to decisions to design values and so on, the practice has been, and again, Annie and or John Ake should correct me if I'm wrong, the practice has been, and I anticipate it will be based on the mean hazard. Because there are precedents and because there are theoretical reasons for doing it. On the other hand, again, not everyone agrees, as you say. But we want them. We want the fractals. We definitely need the fractals. Yeah, we definitely need them.
So, and I think the key thing is that, yeah, I mean, I agree that we absolutely do need them. And, you know, this is funded principally by nuclear-related entities. But I mean, one of the goals is to make this as broadly applicable as possible, you know, and so we definitely don't want to limit anything just because NRC guidance is one way, you know. I mean, I think that certainly there's no, it's worth the effort to try and keep all of the epistemic and aleatory separate, and also we do want to understand what could be reducible in the future and to try and get toward, you know, towards that goal.
No, I mean, if we want to make progress in this process, we need that separation. And we need to track down the epistemic, because otherwise, again, by definition, the aleatory you cannot reduce. So if you're calling it aleatory, you're giving up hope. And a lot of what Norm presented today, again, is getting at the idea that some of these things you can reduce, at least at some point.
We're keeping hope alive, right?
Exactly.
That's what we're trying to do here.
And I would argue that if we're all going to have to learn 12 new parameters, then we better make it worth our while.
Yeah, make it 4.
We're going to have to memorize a new definition and document.
All right. Other suggestions, comments?
I was wondering if there is going to be any work on the interactions between the epistemic and aleatory uncertainties, in the sense that, if I have understood correctly, if somebody is using multiple attenuation functions, that person needs to be credited because of using multiple attenuation function, as opposed to somebody who's using only one attenuation function. So I believe that somehow there should be an interaction between the epistemic uncertainty and the aleatory variability. Is that going to be looked into, or the two would be totally independent?
Well, in a sense, they're related. As Norm said, some of these things will go from one to another, but the way you're saying is a little bit different. You're saying that I'm using like 5 attenuation model, he's using 1.
Yes.
I should get a credit.
Yes.
That's not what, so in this project, we will, an end result will be a set of models and weights to those models. And so we would not give a single model. Okay, so, but
Yes,
part of what Frank had talked about is how do we set those up and try to put more objective weights and fill in model space instead of saying I have these 5 published models, that's all I can weight. We can expand the space or judge their similarities. But our result will be multiple ground motion models that captures the epistemic uncertainty. So for us, this is all integrated into one topic.
I feel that if I'm increasing my confidence in predicting and getting the mean ground motion, there should be somehow this should be like visible.
So the benefit will be as we start to break down, instead of throwing everything into aleatory and giving up on it, right? The unexplained randomness, that's a really big number. we're now starting to pull out pieces and saying, all right, this is actually epistemic. It's knowable. For most sites, I won't know it. Okay, so this comes back to, those XI sub S sub K terms, those individual site terms, for example. If you're doing a big map for the USGS, they don't want to bother with that. They'll just run a standard deviation that covers all of that. Okay, but on projects, you want to be able to. There should be benefit for studies, benefit for learning, right? And so you could say, I've done a site-specific study. I know what that S sub X or XIS term is for my site, or I got data, even better. So my epistemic uncertainty in the value there will get smaller. So that what we had called sigma S, way back earlier, can start to collapse. That can go to 0 as we learn more. And then your total sigma that Gabe talks about will get smaller in the end, so that there will be benefit. But all that we have to say is as we grab things out of the aleatory box and put them into epistemic, there has to be a penalty paid for that until you collect the data or have the information on which you can constrain that new parameter.
Okay, can I ask one more? Just, I don't know which presentation was it, but that was showing I think it was Gabe's presentation on sigma sub mu and sigma sub sigma. Mm-hmm. And I don't know if I understood correctly or not, but it was showing that the sigma sub sigma is much smaller than the sigma sub mu. From an epistemic uncertainty point of view, I tend to think that the knowledge is much better in capturing the mean compared to capturing the dispersion. So why the sigma sub sigma is smaller than sigma sub?
Because I'll try to answer that. Gabe, you can chime in. What I would say is under the ergodic assumption, our sigma values are very stable. That's what Julian showed over the years. That thing doesn't move very much, really. Okay, if you had used the 0.7, you wouldn't be too far off for the last 20 years. What really gives us the uncertainty in that sigma is as you move to really the non-ergodic case. That's the big jump. Okay, and Gabe wasn't running a full non-ergodic case. None of those cases that he said were dropping all of the ergodic assumption. That's where he went from 0.7s to 0.4s. Now you've got a huge impact on your hazard calculation.
Okay.
Yeah, I would add, it's almost the units of these quantities. Again, you know that sigma cannot be 3.
Correct.
And whereas the amplitude, again, where you are going over many scales, many orders of magnitude scales. So it's almost that issue because
right.
you know that the sigma cannot go.
But as we move to the non-ergodic case, when we start to bring these up, our sigma mu's are going to get a lot bigger because we're now saying all of these pieces are knowable, but we don't know them. And so you will start to see some really broad fractals on your hazard, which is starting to say, we don't know that much. I mean, finally, I think we'll get to the point of saying, our uncertainty is this big. In 10 years from now, we'll actually shrink it instead of it always growing.
All right. Jim.
Another comment about Julian's statement. We submitted a proposal to the Southern California Earthquake Center to put out an array of stations at Lovejoy Buttes, which is about 4 kilometers by 5 kilometers in dimension, and there's about 50 rocks there, maybe 30 of them that are really important, to just get at the question, namely, how much difference is there between really close sites on the same granite batholith? It's identical geology. There's a little bit of difference in topography, but 2 questions. One, is there any difference, local difference, right at the precarious rock sites with sites that are as far as you can get away from precarious rocks in between them? And just in general, what's the coherence? I think engineers are very much interested in that. On the scale of, say, less than a kilometer, what's the coherence between 30 or 40 sites? We only got $20,000 to do this. I'm not sure I can do it. And we've had a change in personnel, and I don't know who's going to do it. But maybe if DOE thinks it's real important.
We will put that into
I'm writing that.
Yeah. in our big topic of spatial correlation of the variability, I'll leave that we've covered that topic. One issue would be, are there fragile geologic features that we can be using in the east to do these same kinds of constraints? And I'm not aware of everything that might be out there. There was mentioned earlier by Larry of the paleoliquefaction. That's the other side, that something at least this large has happened. But I think it would be worthwhile a review of potential.
While Norm is writing, any other? Oh, go ahead.
Yeah,
These we call.
you'd mentioned this morning that the models are going to be ready about 2013,
Right.
reviewed 2014.
Right.
And I can see in 2015, if not earlier, there's going to be a publication of a new model.
Yeah, absolutely.
Okay.
Well, this is our plan.
Is there any way that you could consider in this an assessment procedure, a testing procedure, as to whether subsequent models or even modifications of this model itself, I'm already hearing about the NGA West, if you will, needing to reconsider the magnitude dependence on sigma. Is there a way that, a mechanism that you could test subsequent models as to whether this NGA East is still a valid model to use?
You mean running sensitivity analysis and so on?
Whatever
Absolutely. It's a part
methodology
of
it would
the thing.
take to
It's a part
say-
of the plan. No question about it. So the process is that there will be a bunch of models, many models, and then they will be reviewed not only at the end, but all the way through the process of being developed on input of the models and how they are being developed and so on. And then, as I showed, there is a sensitivity, the impact of the hazard. So before the models are published, final for use, definitely sensitivity analysis will be done. No question about it. And you guys will be part of it. I mean, you are going to see the results. It's not that suddenly you get a paper out of
Well, we've had instances now of using a certain model, certain suite of models for attenuation relationship, and in the SSA and the BSSA, there's a new model that's been published, and we've got to deal with assessing whether the existing model is broad enough range to capture the technical community, as SHAC Level 3 is supposed to do. How do you know that with the new model if we don't have a particular process to really tackle that down?
Julian has a comment.
Can you make another page here? I don't know how to do this.
Two things. One, he's probably being too modest to say it, but I think eventually Frank's tools will allow any, I hope it will become one day that anyone wants to publish an attenuation equation. First, you have to go onto Frank's website and see, are you adding anything to our knowledge? If it's just to put your H factor up, then take it away, because there's too many models out there. And we can think our models are different, and as we found out to our discomfort, where you think your model is not necessary. And just before we saw his maths, we published a paper showing that the NGA data fits the NGA models fit the European data very well. So we thought, okay, and then we saw his maths, and we were very distant from the NGA model. So it's a very useful tool in that sense of when new models are produced, do they tell us anything new?
But in your case, you were distant because of the sigma term.
Exactly, and we
right?
tend not to look at the sigmas.
Right.
We look at the medians, which is a paradigm we have to shift. But your point is very good. We've been discussing the last few days with Kevin Coppersmith about SHAC Level 3, SHAC Level 4, regulatory assurance, and stability. And when Kevin talks about stability, he means a seismic source characterization model that will have a shelf life of at least a decade. In other words, that it captures sufficiently what we know and what we don't know, such that any new information is unlikely to require a revision of the source model. And I think in a seismicity and geological model, that's probably feasible. I'm not convinced that we get decade-long stability in ground motion, and we have to be careful when we talk about a SHAC procedure giving us that, because when this 7.5 earthquake in California that I keep threatening Norm with comes along and gives him accelerations. I mean, you remember that we had all the 1997 models in SRL. And then these earthquakes happened in Turkey and Taiwan, and everyone plotted the data against War et al. 97, and oh, look, these accelerations are really low. And now we have a model which tracks those low accelerations from high magnitudes. We have to be prepared that our models might change with every well-recorded, significant, large earthquake. We don't have stability, and
I will just tell you, I have to keep getting my digs in on what we did on NGA. We didn't just, if you look at any of our models, Chi-Chi, for example, is a very low event still. So we don't go through Chi-Chi directly. The other part is we looked at suites of simulations for California. So there is more than just, oh, I've got another earthquake, I got to redo my model. If you were doing that, you would be back at the mercy of the regression. And we're trying for stability that we actually don't let that happen in the models. We'll see what happens. Parkfield was a great check for us. It worked really well. But you'd say, well, magnitude 6s, you know what happened. But that was one where I think we ended up showing where none of us had used that data. We actually predicted it well. We'll see what happens.
I think Norm is correct. If we get a magnitude 1 event, it's very unlikely suddenly we change the models and so on because of one event and so on. But what we promise in this
Yusuf,
thing,
if you get a magnitude 6, if you get a magnitude 7 in the east, it could change all your models.
what is that is going to change the whole profession.
But we've had one, Saguenay, and we've declared it an outlier.
You declared
Right? So it didn't change
I
our
wanted to
model.
conclude. What we promise, we are going to develop a set of next generation attenuation models that basically have gone through various levels of the review that we are all comfortable with. So that is the promise. Now, again, as Julian says, suddenly we get back to the 8 and so on, somewhere is a little bit different. Sorry, yeah, Larry.
This may be a long-term action item because it'll take some time to actually have the ground motion models and have the weights set, as you've described, Norm. But I would recommend as a long-term action item, we will have the seismic source characterization model by then. And we should have some test sites, as we are doing now on the source side, combining the two inputs so that we can look at the results before we publish.
Sure.
That's good.
And Gabe, our hazard analyst, is already very familiar with that source characterization. I was going to say that we do have the same hazard analyst. So Gabe Toro will have that model, the seismic source characterization model, and is specifically taking the role on this project so there is that consistency.
So we have hazard
Efficiency.
feedback expected here, and it will be not for one location, but for probably the same 7 representative sites that you ran, and we'll start to get that as well. So.
I want to go back to the diagram that was shown earlier from Gabe Toro's paper, where it's partitioning uncertainty into epistemic and aleatory on one axis, and then parametric and modeling on the other. And that diagram says that the aleatory variability due to the mismatch between recordings and simulations is, well, it's saying it's aleatory. But if you think about what you're doing in that case, you've got a model. If it were a perfect model that really described how the Earth behaves, and if you had exactly the right parameters for that model, then I can see why you'd call that mismatch aleatory. But it seems to me there's some kind of epistemic uncertainty involved because you don't have a perfect model, and you don't know the parameters of the model, even if it were perfect.
But our concept is that you have had the opportunity in your validation to optimize all of those parameters. And so this should be the variability that's left after optimization. Now, whether you say I took a slit model inverted for something else as the value, then you would say you were stuck with that, and that's probably, you're right, it has a little piece of epistemic. Other people, I know, for example, Yehua Zhang had actually optimized the slip model for his particular simulation technique. So then in that case, he has tried to get all those source parameters that he can constrain the best he can to fit the data. So there's going to be parts of that. Are you at there yet?
I agree that you've got to count it.
Right there.
Yeah, I agree you have to count it, but it seems to me a lot of what we are calling aleatory in the top right-hand box is really epistemic uncertainty due to the failure, the imperfection, inadequacy of the model, and of your knowledge of the right parameters.
Inadequacy is like simplicity. Okay, so if I have an empirical or just a parametric equation that's not physical, all I have for wave propagation is distance. All I have for source is magnitude. The penalty I pay for that is unexplainable randomness. And so as long as it's a part of your model that we can't explain, we need to stick it in that box. Whereas the bottom part is randomness that's explainable by that particular model. I think it's difficult it is absolutely model dependent, but it's difficult to say that term, that part is actually epistemic. We have to include that. As long as it's unexplainable randomness, it must show up in what we call aleatory. Mm-hmm. That's the only place we can put it.
Okay. All right. Gabe.
Actually, I want to go back to Jim Maroney's questions. It seemed, well, actually, and I'm speaking as somebody who wrote a paper on Eastern U.S. ground motions just a couple of months before Saguenay. So Dave Boer has the same honor. But if we do our job right, it is unlikely that a new model or a new event will change things substantially. If we do our job right, it will be covered within that. But on the other hand, if we go overboard and put huge uncertainty bounds, so that we're always sure that any new model is covered, then we're not doing our job right. So doing the right job, and that gets probably into Frank's information theory kind of ideas. If we're doing a good job, we have to strike the right balance between those two sides. Being too narrow and be almost sure to be overridden by the next event, being too broad that we're uninformative.
Right.
And Frank will tell us how to do it.
Julian alluded to this. I mean, if we take our models and we drop them into these magic Simmons maps or whatever those are called, when you get a new model, you also just plot it in that space. And if it's showing up outside, then we got a problem. If it's falling inside, we say, well, it's already captured. Right? Then the question is, do we need to redistribute weights or not? Well, does it have fundamental new information that really says we had our weights shifted wrong? But I think we're going to be in a much better situation for doing this than before. There'll actually be some objective way of saying, yes, we had that one captured, as opposed to plotting the medians, which we just have said could be missing the whole key aspect of the model, versus plotting the sigmas separately. It's together. And I think, Frank, correct me if I'm wrong, in your metric, you're using some basic hazard calculation, right?
In the part which I didn't use
right. Okay, so it's actually, we need to have Frank come back for round 2 of this stuff, because it's a completely new way to think about things, but gives us a structure that really lets us move forward in an objective way.
And also, Frank promised to have training that people in the U.S. can run his program also.
Frank, this could be the Nobel Prize.
There you go.
I guess that I missed that exactly, because I was curious about that of like the implementation of this. So this is a program that you've actually developed and that other people can run? So like we can bring it into the NRC? Or no, you just, we call you and you, okay. That's why I was surprised to hear that.
No, part of what we expect by the end of this project is that machinery will be up and available to anyone to use. There's got to be somebody other than Frank that understands it,
Right.
okay? And it needs to be fairly simple to implement. Understand?
So I think Norm is correct. So by the time that we have some models the machinery should be ready to run these things, show how close they are, how far they are, and so
And
on.
ideally, at the NRC, when a new model is published in 6 years, you would take that, you would code it up, and then you would pop into that model, and you'd see where it fits.
And it will be open source.
Yeah.
Okay. And so then
Mathematica. Well, yeah.
So when the tool's available and we all understand the theory behind it and understand what exactly it's giving us, then we should be able to come up with some sort of a protocol or some sort of methodology to assess that we can put out there so that people understand exactly what we
And
expect.
exactly that question, that now we have a new model. Should we include with equal weight, less weight, higher weight?
But as you could get a new model that still falls within your space. But if I get 10 new models and they keep showing up in the same area, that may tell me I actually want to weight that a little higher if there's more basis for it. So was it captured? Okay, was it within our range? And then back to the center and body of our distribution, have we got it in the right place? So I think things will be, it's to come back in a year and we'll see where we are in this, but I think we'll be in much better shape in terms of setting this whole thing up.
Okay, excellent.
That's a lot on you, Frank. For right
So,
now.
Frank, I added Frank's program. All right. Anything else? Any comments? Any questions? Paul?
Just a question. What's going to be the process for addressing the Sigma action items?
We are going to have a working group on Sigma. And it's still not 100% well developed. So we are going to have, like Paul, like other working groups, simulation, ground site, and so on. We are going to have a working group on Sigma that they're going to address. And one thing I wanted to mention, because a couple of people asked, the working groups, members of working groups can work on the project, but they definitely we encourage them to pass the task and project to outside of their working group. It's not like 2-3 people will do the whole thing. So if there are 2-3 people in working group, it means they just coordinate the task. They can do the task, but they diversify and they give it out.
Yeah, and so beyond, so the way the project is set up is the working groups basically help to define the issues that need to be looked at, to look at how that would go about, to determine, is this something that should be done within the project, should RFPs go out, that type of a thing. That what they'll do is they'll put together sets of recommendations. Those recommendations will go through a technical review committee, which is a separate independent committee. Anyone on that committee is not doing any of the project work, so that they're very independent. And they will add their 2 cents and provide recommendations to the Joint Management Committee that Yusuf talked about this morning, who are those of us who are representatives of the funding agencies. And what we'll do is, by unanimous a decision will determine what to fund. So it's not just that the working groups kind of get to do whatever they do. They're really trying to develop the technical programs in each of their technical areas. And then there is a review, and then finally the JMC will make the final decisions.
I'd add one last thing, because I'm afraid I have to run to the dentist, and my schedule is tight. But we need to have this. You guys have just seen a sort of in-depth look at Sigma, and we haven't taken the whole program and presented it to everybody in all our working groups, and that needs to happen soon, right? I guess we're expecting the big workshop in June to really say, here's how all this stuff fits together.
Right. And to support that work, on Monday we did have a meeting with multiple groups, the Joint Management Committee, the TI team, the technical review group, and the participatory peer review panel. And there was a lot of work that was done there in determining how this program will be undertaken. And so right now I'm developing basically a program plan based on all of the input we got. I did a draft one, and we're going to do quite a bit of revision to it. And so we will make that a public document, and hopefully within the next few weeks. And I hope that that will clarify to everyone how we want to go about it. We wanted to leave it a little bit flexible. When we set up the project and really get a lot of input, and we feel like we're sort of at the tail end of pulling a lot of that input in, and so that document will be available to the public so that everyone gets a sense of where we're going and the technical issues to be addressed.
Great. Yes, Annie. And then one last thing. We are going to post all the presentations today at Peer website. We are going to send you a link also if you want to see these things and presentations. We are going to send you the link. If you have not registered for this workshop, it means I don't have your email address. Send me an email, and you want to get into that email list. We are going to send a mass email list to all of you to give you the link as well as the PowerPoint presentations. If there is, okay, Julian has
a request. When you do that, can you put everyone's address in the BCC?
Yeah, absolutely.
Please not to use reply to all to tell you that.
No, that's a good one. That's except Julian, who likes to see all the comments around. All right. Is there anything else? Otherwise, thank you very much for coming. Appreciate that. We will be in touch and through emails, and then we are going to have more public workshops also. Thanks a lot.